In this tutorial, we'll be discussing what you should have learned in week 2 of Chem 119 at PNC. The first thing that we're going to talk about is temperature. There are 3 primary scales: Kelvin, Celsius, and Fahrenheit. Kelvin is the scientifically determined temperature scale, meaning that the zero starts at absolute zero, where all matter stops moving. Celsius is the metric temperature scale. It starts where water freezes. And then Fahrenheit is the English. Even though we have the equation for Kelvin here, Kelvin is equal to degrees Celsius plus 273. For every degree that Celsius goes up, Kelvin goes up 2. Goes up as well, I should say. It goes up 1 for 1. We're going to focus more on Celsius and Fahrenheit, however, because that's more of what you'll learn, what you'll deal with when you're dealing with nursing. So you need to remember this equation here. Fahrenheit is equal to 1.8 degrees Celsius plus 32. Let's do a couple practice problems with this. Convert 35.5 degrees Celsius to Fahrenheit. So the Celsius to Fahrenheit equation is this one once again. Fahrenheit is equal to 1.8 degrees Celsius plus 32. Alright, so we're going to plug our numbers in. We have 35.5 degrees Celsius. That's going to go right here. Plus 32. Order of operations indicates that you do the multiplication first. So 1.8 times 35.5 comes out to be 63.9. Then you're going to add 32 to that. That's going to come out to be 95.9 degrees Fahrenheit. If you have a patient with this temperature, it's very possible that they'll have hypothermia because their temperature is far less than what would be considered normal. This next example is for if somebody had a fever, 103.5 degrees Fahrenheit. So we plug that number in for F. Once again, order of operations, we want to get X by itself. We want to get the degrees Celsius by itself. So we're going to subtract 32 first. That comes out to be 71.5. Divide each side by 1.8. That comes out to be 39.7 degrees Celsius. It's very possible in the medical world that you'll have to be able to do both Fahrenheit and Celsius fairly regularly. Elements and symbols. Symbols are 1 to 2 letters to represent the element. The first letter will always be capital, while the second letter will always be lowercase. Knowing this, let's say we have MnCl2, just a random compound there. The first letter is capital. That's how you know you have a new element. So capital, lowercase, that means that M and N go together when you start looking at the periodic table. Then the big C indicates that you have another element here. And then the lowercase l means that those two go together. If we have, for instance, BCl3, uppercase for the B, uppercase for the C, that means B is all by itself. The two letters only go together if it's a capital and a lowercase next to each other. So ionic compounds have cations and anions. Cations are positive, anions are negative. And they're held together by electromagnetic attraction, meaning that the positive and negatives, the opposites attract. And they're really super strong bonds. Positive and negative charges must then cancel out and be neutral for a compound. And we do this with the crisscross method. For instance, magnesium is here, while nitrogen is here. You need to be able to know what the charge is by looking at the periodic table. So plus 1, plus 2. Magnesium is a plus 2 because it's in the second row. And then this is plus 3. Then the carbon group actually changes, and then it starts becoming negative. So negative 3, negative 2, negative 1, and 0. Nitrogen is then negative 3. We're going to crisscross these numbers to become Mg3N2. And that's how you balance it out, because you have 3 magnesiums with a +2 charge, and you have 2 nitrogens with a -3 charge. That's +6 and -6 to equal 0. One thing you want to be careful of is if I would have put magnesium with a +2 with oxygen, which is right here, with a -2. When you crisscross those down, you notice you have 2 and 2. That can then be reduced to 1 and 1, so MgO. So naming compounds, now that you have the formula. So let's reverse this process. So identify the cation and the anion. So we have lithium, which is here, and we have sulfur, which is here. So name the cation by the elemental name or the polyatomic ion name. So lithium. Determine if it's a transition metal. It's not a transition metal. Transition metals would be in here and in here. So since it's not a transition metal, I can go on to the next step. Name the anion using the first syllable of the element. So sulfur is sulf. And then ending it with ide, so sulfide. So this is lithium sulfide. Let's do another example. Fe is iron. That is a transition metal, which means that I need to figure out the charge. We'll come back and do that in a minute. So I'm going to put a parenthesis here so I can figure out the charge and put it there later. CO3 is a polyatomic ion. That's carbonate. The reason why I was coming back to that is because I want to make sure that I have whether or not I have a polyatomic ion there. If I have a polyatomic ion there, I put the parentheses around the polyatomic ion. Now up here, we crisscrossed to get these numbers down here, these subscripts. This time we're going to uncross it to get the numbers on top. So we have a 1 here, and we have a 1 here, because they're invisible numbers. That's supposed to be a minus. The first one's always positive, the second one's always negative. Carbonate is supposed to be a -2, not a -1. So we're going to multiply both sides by 2. So that comes out to be iron 2 carbonate. So under here, we're going to do, if it's a transition metal, uncross and double check. So we're double checking the charge of the anion. Let's go on to molecular compounds. Difference between molecular and ionic. Ionic is giving and taking of electrons. Molecular is sharing the electrons. The bonds are not as strong as the ionic compounds. And it's nonmetal bonded to nonmetal rather than cation bonded to anion. Although you will see a trend up here for the ionic that it's a lot of the times it's metals and nonmetals. Not 100% of the time, but a lot of the time. Whereas down here molecular, it'll be nonmetal and nonmetal. And these use prefixes when they're named. So, first, name the first nonmetal by this elemental name. So, N is nitrogen. I didn't have to change the name at all. If it's more than 1, use appropriate prefix. I only have 1, so I can move on. Name the second element using the first syllable of the name, followed by ide. So chlorine becomes chloride. Place a prefix of the number of atoms in front of that name. So 3 is tri. Now, even if it was 1, you would put monochloride. You won't put mononitrogen trichloride. You only use mono for the second element, not for the first element. Let's do another one. First element is boron. 2 is di, so diboron. Hydrogen becomes hydride. 6 is hexa, so diboron hexahydride. And then finally, writing the formulas from the names. So you write the symbols. So let's say we have boron trifluoride. Write the symbols of the order. So boron and fluoride. Then use any prefix in the subscript. So there's no prefix here, so it's going to be an invisible 1, and the second one is tri, meaning 3. We can also do an example of carbon monoxide, something you're probably familiar with. Carbon is C, oxide becomes from oxygen, ox. No prefix here, so it's an invisible 1. Mono means 1, so it's just CO. And that is what you should have learned in your second week of Chem 119.